Our next speaker is Sabina Salkic, and she is going to make you maybe think twice about the next glass of water you drink, and I'll let her explain why.
Good afternoon, everyone. I'm Sabina Salkic, and I will be telling you about our work on how Raman spectroscopy can be used for monitoring photocatalytic degradation of X-ray contrast media. So, Kentucky water resources become a growing concern as state develop as rapid rate that has been recently. Many organic compounds end up in wastewater. During wastewater treatments, these compounds are not necessarily removed. So they end up in our drinking water. One of classes of such compounds are X-ray contrast media. These compounds are used for diagnostic imaging of soft tissues. Like I have example of GI X-ray. So they can be taken orally or they can be injected into a body. So for each application, 200 grams is used, 3.5 million kilograms is used each year. And these compounds are not metabolized by body. So here are two compounds that we are studying, ditriazoid and iohexol. The two things that I have in common are aromatic ring and iodine, which are important in our work. The steps that are involved in photocatalytic degradation are light comes in and reacts with titanium dioxide, then leads to formation which reacts with oxygen and water, then reacts with eventually organic compounds, then leads to something simple molecules such as carbon dioxide and water. Previous work has been done with LCMS monitoring the products, which has this advantage. Preparation of sample is too complicated and time consuming. So, and it's done every 30 minutes. Our goal was to find something that's faster and simple when it comes to sample preparation, but eventually yield same results as they have done in the past. So we chose Raman because it's a little sample is required, preparation of little sample is required, not sensitive to water and turbid samples, because our photocatalyst is suspended in a solution. Also, by measuring molecular vibration, we can connect changes in the spectrum to changes of molecular structure. Here I'm having ditriazoid and iohexol on the top where we took spectra before it was introduced to UV light. Each peak represents vibrational modes. On the bottom, I'm having integrated area as a function of time where we are monitoring the changes of each peak individually. So what we can see that peaks are decreasing over the time, so we can confirm that degradation is occurring. So, in addition to degradation, we can see the changes to the peaks relative to one another, which provide us clue about mechanism of degradation. And then I invite each of you individually to come by my poster where I have more data with more details to explain. Future work, what we have done, measuring kinetics every 30 minutes, but we eventually want to go faster. Like, for example, 5 minutes. So we want to know what is happening to reaction during those 30 minutes. Also, we want to use LCMS and Raman in same time to identify intermediates that are forming. This can be done with a different X-ray contrast agent like upamidol. Also, we can do this with estrogens as inform runoffs and pHs, which are carcinogenic byproducts of coal and oil combustions, with using the SERS, which is a surface enhancement Raman spectroscopy, to improve the Raman signal. At this point, I would like to thank Dr. Matthew Nee as my advisor, Dr. Maddox, who help us with calculations, who provide us a server for vibrational calculations, and Bango Yan, who loaned us his UV lamp. And this work was founded by Ogden College of Science and Engineering. And thank you, and I look forward to meet each of you at my posters.